Good day, learners. Welcome back to our mathematics class. In today's class, we are going to continue our differential calculus. In one of our classes in differentiation, we have talked about first principle. But today, we're going to look at limiting value of a function. What do we call limits? The word limit in a nutshell, it means when a number is getting closer to a particular value. That is, if you have a value, say 2.01, 2.001, 2.002, 2.003, that's the value of our x. When you find the square of that, of s squared, you are going to see that this number continues to decrease, So when it continues to decrease to a particular value, we call it what? A limit. So as it approaches to a particular value, there is a limit. Now, let us now move properly into this and we'll discuss about the properties of limits. If you are a new member on this channel and you have not subscribed, kindly click the subscribe button and click the notification bell for my subsequent content. And do not forget to share to other learners for them to benefit. So, let's dive in. Properties of limits. These are the properties of limits that are going to take us through how we are going to solve limit questions. Number one, limit k as x approaches a is going to give us k. This k refers to a constant. So limit of a constant is equals to that constant. What do you mean by that constant? If you say 7x, 7x is not a constant. But if I remove this x, 7 is a constant. So in this case, the limit of a constant as x approaches a equals to a constant. 2. Limit of, in open bracket, f1 of s plus f2 of s plus f3 of s to fn of x as x approaches a. We are going to open the bracket with the limits. Each of them will have their own particular limits. Limit f1 of x as x approaches a plus limit f2 of x as x approaches a plus limit f3 of s as s approaches a, and so on to limit of f of x as x approaches a. The third property is that limit f1 of s minus f2 of s, we open the bracket as we have done in the addition. So each of them have their own limits. Limit of f1 of s as s approaches a minus limit of f2 of s as s approaches a. Likewise, the number 4, limit of a product f1 of s times f2 of s times f3 of s equals to limit f1 of s as s approaches a multiplied by limit f2 of s as s approaches a multiplied by limit f3 of s as s approaches a. This property is a division. Limit f1 of x divided by f2 of s as x approaches a is equals to limit of f1 of x as x approaches a divided by limit of f2 of s as x approaches a. The number 6 is that limit of k or f of x as s approaches a. We know very well from here that k is a constant. Then this k will be taken out. So we have k limit f of s as s approaches a. Now, on this number 7, we have to note that limit of 1 over x as x approaches infinity is going to give us 0. Meaning, 1 divided by infinity will be equals to 0. Example 1. Evaluate these limits as x approaches 1. That is, anywhere we see x, we are going to introduce 1. Limits 4x cubed plus 3x squared plus 2x minus 2 as x approaches 1. So this means limits 4x cubed as x approaches 1 plus limits 3x squared as x approaches 1 plus limits 2x as x approaches 1, then minus, or let me say plus, limits of minus 2 as x approaches 1. So this is the addition of limits. So in this case, we now substitute. Then this one will be 4. Now, we can have limits 4x cubed as x approaches 1 plus limits. So here we have 3 as a constant. This 3 is a constant. 3 has to come here. Then 3 limits x squared as x approaches 1 plus this 2 is a constant. 2 limits x as x approaches 1 plus limits of minus 2 as x approaches 1. So we introduce our 1. So we have 4 bracket 1 cube plus 3 multiplied by 1 raised to power 2 plus 2 in bracket 1 plus the limit of a constant equals to that constant minus 2. So here 1 in 3 places, 1 times 1 times 1 give us 1 times 4 we have 4 plus 1 in 2 places give us 1. 1 times 3 we have 3 plus 2 times 1 we have 2 plus times minus we have minus 2. So this one is plus 2 minus 2 cancelled. Then 4 plus 3 we have 7. So this limit gives 7. Example 2. Evaluate this limit as x approaches 2. So we have limits of x minus 2 in bracket x squared plus 3x minus 2 divided by x squared minus 4 as x approaches 2. Normally when you look at this is a quadratic equation. We have to factorize this. While this one is a difference of 2 squares. But when you look at this quadratic equation very well, minus 2 multiplied by 1, we are going to have minus 2. You look for 2 factors that when you multiply together, you will get 2. When you add them together, you subtract, you are going to get 3. There's no factor that can fit in. There's no factor. In that case, we leave it that way. Then, we are going to have it this way. Limits of x minus 2 and x squared plus 3x minus 2 divided by this x squared minus 4 can be written as x plus 2 and x minus 2. That's the difference of 2 squared. So we have done this in some of our videos. Now, x minus 2 cancel the x minus 2. So we have limits x squared plus 3x minus 2 divided by x plus 2 as x approaches 2. So here, we substitute our 2. So we have 2 squared plus 3 times 2 minus 2 divided by 2 plus 2. So 2 squared give us 4. That's 2 times 2. Plus 3 times 2 give us 6. Minus 2 divided by 4. That's 2 plus 2, 4. So we have 4 plus 6, we have 10. 10 minus 2, we have 8. So divided by 4. 4 here, 1, 4 here, 2. So the limit is equals to 2. Example 3. Evaluate the following limits. Limits x squared plus 4x minus 12 divided by x squared minus 2x as x approaches 2. Now, when you look at these limits, x squared plus 4x minus 12 divided by x squared minus 2x as x approaches 2. This upper factor, which is this numerator, is a quadratic equation. Let's try to factorize if it can be factorized. Minus 12 multiplied by 1, we have minus 12. So looking for 2 factors that when you multiply together, you get 12. When you add them or you subtract them, you're going to get this 4. We have 6 and 2. Let's guess the sign. Plus and minus. Okay, plus 6 multiplied by minus 2. Then plus 6 minus 2. So this is multiplication, this is addition. Plus times minus, minus 6 times 2, 12. Plus 6, I have 6 now with me, and I'm holding 2 now. If I pay 2 now of 6 now, it will remain 4 now that I'm having. That is plus 4. Definitely, I'm going to eliminate this 4s. I will remove this 4s and introduce my plus 6 and minus 2. Here, I have limits s squared plus 6x minus 2x minus 12 divided by s squared minus 2x as s approaches 2. Let's group. So limits, what is common here? We have x bracket s plus 6 minus what is common? 2 bracket x plus 6. Don't forget, what is here must be the same thing. Then minus times plus, we're going to have minus divided by. Now look at it. What is common here? We have x bracket x minus 2 as your x approaches 2. Fine. Then we have limits. So pick those one outside, x minus 2, then x plus 6, then divided by x in bracket s minus 2 as x approaches 2. Then x minus 2 cancelled s minus 2. We have limits x plus 6 divided by x as x approaches 2. So let us now introduce our 2 here. We have 2 plus 6 divided by 2. So 2 plus 6 we have 8 divided by 2 gives 4. Example 4. Limits of these values 3s cubed plus 2s squared plus s plus 1 divided by s cubed plus 2s plus 5 as s approaches infinity. Now, how do we go about this? Limits 3s cubed plus 2s squared plus x plus 1 divided by s squared plus 2x plus 5 as s approaches infinity. Do not forget what I explained to you that you should note that limits of 1 over x as s approaches infinity is equal to 0. So we want to look at the way we can achieve 1 over x in this. So we have limits, this is s cube. So we have limits 3s cube divided by s cube plus 2s squared divided by s cube plus x divided by s cube plus 1 divided by s cube all divided by s cube divided by s cube plus 2x divided by s cube plus 5 divided by s cube as x approaches infinity. Fine. This goes here. This goes, we have 1x. This here 1. This here it went 2. This goes, we have 1. S cancel, we have 2. So we have limits 3 plus 2 in bracket 1 over x plus 1 over s squared plus 1 over s cube divided by 1 plus 2 in bracket 1 over s has cancelled 1 over x squared plus 5 in bracket 1 over s cube as x approaches infinity. Now we have, if we introduce our infinity, we are going to have 3 plus 2 in bracket 1 over infinity plus 1 over infinity square plus 1 over infinity cube divided by 1 plus 2 in bracket 1 over infinity squared plus 5 in bracket 1 over infinity cube. Now, 3 plus 1 over infinity give us 0 times 2, 0 plus 1 over infinity squared, 0 plus 0 divided by 1 plus 0 plus 0. So finally, we have 3 over 1, which is what? 3. So this is the way to look into limits. If you are a new member on this channel, kindly subscribe to my channel and click the notification bell for my subsequent contents. And don't forget to share, like, so that other learners can also benefit from it. Let's watch out for the other aspects of differentiation. Thank you very much.